Hi, my name is Alexander Zelenin. I'm experienced software engineer. Today we will solve unique Morse Code Words problem from leetcode with JavaScript. The plan for today is next. We'll observe the problem and find what is meaningful for the task, what is not. Second, we will design our algorithm. Third, we will calculate complexity of our algorithm. Fourth, we will try to find out is this algorithm efficient enough and what we can optimize here. Fifth, we will try to implement algorithm. Sixth, we will test that everything is fine and debug our code if it required. And seventh, we check our complexity, that it's the same it was originally calculated, and see what findings we have during the task. So let's go. Loading. Okay, it's loaded. So let's see what we have here. We have international Morse code standard, where every letter maps to dots and dashes, something like that. We have an array of all the letters we have here. So every word should be right as a concatenation of all letters we have here. So for example, CBA will be resulted to something like this. We need to return how many different Morse combination for words we have, because the same Morse code can result to different words. But I just want to mention that in Morse you do some pauses between the letters to ensure that the receiver understand what you are sending. Otherwise you will end up with something like that. So we will receive, for in this example, 4 words. We will need to calculate Morse code for them and see how many unique words we have in total. So let me just see what constraints we have here. So the length of every word, maximum 100 symbol. The count of words is maximum of 100. Each word will be from 1 to 12 symbols. Words will only consist of lowercase letters. So it might be useful to use some ASCII code later on that I had used in previous task. It looks like it's related to this one also, to have a simple transformation. So let's think what options we have here. So first of all, we're receiving an array of words. Let me copy this one. Oh, it's too big. Maybe if I will zoom out a bit. Yep, like this. So what is the problem? Okay, so we have these words and we will go through every of them. Let me do like this. We'll go through every of them and we'll find the proper representation. So for example, for this one, representation will be like this. For the first letter, we will need to find this representation, and we will need to store this representation somewhere. So we will store it. At the start, I think can start with the dictionary, where this will be key. So we'll use this code as key, and we'll check in our dictionary if such keys exist. So for example, we are going for first one, we create our dictionary is empty, so we add one symbol, add one to our counter, so we have like one combination. When we go with the second one, the code is the same. So we look up to our dictionary and found that it already exists. So we don't do anything. And we will repeat this operation for how many words we have. So originally we have like 3 steps here. First step is going through array. Second step is transforming the word to the code. Okay, to the code. And third part is to take a look at our dictionary and check that it has it has this word or not. Let's see what complexity we will have here. First of all, we will need to have at least two variables. The first variable is length of array. Let it be L. Let me do it like this. L. The second one will be no, not L. Let it be A, like array. The second one will be the length of every word. Let it be W. So convert word to Morse code will took to up to OW time. Since for like every letter we have some representation, then we make join of this representation and so on. And we do this encoding 8 times. 8 times. So at the end we have something like O, A, W. We multiply this because we do word encoding the count of 4 times. Can we optimize this somehow? Let's think. Like, what is this calculation was for time complexity. Time complexity is how CPU is used depending on incoming data. And for space complexity, which is how memory is used depending on incoming data, we will need to store dictionary. In the worst case, this dictionary will have separate code for every of word. So it will have like the same, since for every symbol we'll have like encoding, so we will end up with something like the same. So we'll have totally same one. I'm not sure that we can dramatically optimize time complexity in this case, like in a worst scenario, since we still need to check every word. We can, of course, cache some parts of words or words entirely, but I didn't think that it will save a lot of time. Anyway, we will need to go like through symbols to compare them and so on. But for memory consumption, I think we can use another structure. We can use something like tree, where we can store something like that. We can store dot or dash on every level. So, for example, how we can encode this one? We'll encode this one as like line, dot, dot, line, dot. And we have like a tree like this, and right now it doesn't save anything to us. But when we go for second one, it will be the same, so there is no big difference. And in the end, we have something like star or some another symbol mentioning that this is the end. So, and we have the second one, this one, which can be stored in this structure, like first symbol same, then 3 dots, then 2 dashes. So instead of dot here, we can store like dash here and additional dot. So instead of saving entire word, we can go with something like this, and we will store only 2 symbols that are different from previous one, which is will be much cheaper, since like on every level we have only 2 combinations, and like so let me think for a second. We have maximum 12 letters, and a lot of them will have the same structure. But like in worst case, again, it's possible that no, anyway, at least some part of word will be reused. Like word start with dash or dot, so we at least save some space. Like at this part we can have only 2 words, right? 2 letters. At this part we can have like 4. At the third step we can have 8. So we have maximum of first of all, for every letter we need to have some combination, right? And for every word, so 32. So like at least this part should be very common. But the combination after this can be differ. But okay, let's try to calculate what space complexity can be with this approach. I don't think we will go on this video today, since it's complicated a bit. Not so complicated, but it will take time. We will not go by this reason. If you want me to make a solution with this approach, leave a comment, please. So, what is possible space complexity here? In a good scenario, we'll have only small overlap. Like in this case, it will be only 2 symbols. It's like nothing. In other cases, if we'll have words by 12 symbols, and there will be like 100 words. Okay, it sounds not so easy to calculate it properly, like on the fly. So I'm not sure how it will differ. I think in worst case we will end up with something like that. So for example, what if we will have only two words? Like in worst case, we will end up with two of them with totally different one. Like one of them will start with dot, one of them will start with dash. But since count of letters is finite, there should be some optimization. But okay, I don't want to stop on this now for sake of saving time. So let's go for implementing our initial algorithm, this one with this complexity. So we will have three steps. One of steps is converting to Morse code. So let's go to our code and try to write something. So we need to copy the array of Morse codes. Let me add it here. Oh, I cannot format it well, but okay. So let's just save them. It will be from 0 to 25, right? From 0 to 25, like this. So we have words, and let's create an additional function and call it encode like word to Morse. This function will encode the word itself. To encode words, we will go through every symbol of this word, and we will create a resulting array, and in the end we will join this array. So const result array return result join all the symbols with spaces. Then we go through every symbol in our word. Let I okay, and current letter. We're getting current letter, it will be word I. We need to get current char. Let me take a look. We have only small chars, right? That was from conditions. Consists of only lowercase letters. So lowercase letters start in ASCII table with symbol of 97 and up to 122. So we can remove from our chart code 97, and it will be mapped to our codes. So the A will have 97, minus 97 will be 0, and we will get the first letter, like this. So the method called char code add, we getting char code, we remove 97 from this, and we get it from codes. Maybe we don't need the additional variable. I don't want to use it. No. This one's still better. So we got our code, and let's put it to result. I prefer to store it in meaningful variables for easy understanding, because if I will like use something like word I in couple of places, it will be easier to miss something. So we have a function word to Morse. Here we will have a couple of things in our main function. So the main function will go through all words we'll transfer word to the code which we already implement, put it to some dictionary, try to put into some dictionary. Otherwise, not otherwise, it is, if it's possible to put in dictionary, then we increase our counter. So we have two things. First one is counter, which is 0, and we will need to return this counter. And second one is our structure, which will be dictionary, where we can save our keys. So, and we go through all our words. Since words is array, we can use for each construction to go through every of them. And we can use arrow function here. So by this construction, we took every word from our array. So for example, we have array like this. So word will represent like gene, then, gig, message, and so on. So for each of them, we will call word to Morse function. Here we will have Morse representation. We will take a look if our structure have this Morse representation, and if it doesn't have, this means not. We will increase our counter by 1, and we will add our word here as key and just true. So generally that's all. Let's try to run our code and see how it will work. So at least for this one, output is exactly like expected. Let's try to run. Okay, it's a success, work faster, and so on. Everything is nice. So we solved this problem. Now we will need to see what complexity we have here. You can set on pause and try to calculate complexity by your own. So let's start with space complexity and time complexity. So with the space complexity, so we have two functions. So first we will calculate it for inner function, for this one. So for space complexity we use result. Result are originally at least the same length as word, so it will be ON. There is nothing else is stored, and result in the end is concatenated to a string. For time complexity, we have this cycle which go through every letter in word and get proper code. So everything inside the array is just 1. It's simple operation, nothing special, but cycle itself make ON. Let's go for this one. So space complexity and time complexity. First of all, we have just one structure here, so everything will be around this one. For count of keys here, it will be O. I have had used two variables. A is array and VW for the word length. So OA keys we will have totally, so up to word's length. And every key will be a string up to OW of length, since this one have a space complexity of OW. So we put OW A times. So we have OA multiply W. And for time complexity, this cycle is OA. So we go through every word. So this itself took A time. And this method took OW time. So it will be like again. Again, we got same. OAV. Nice. So what we had solved task, we had calculate our complexity. It's the same that it was expected initially. Again, if you want me to explain more about structures like this and make a separate video regarding to that, set likes, comment, and don't forget to subscribe and set like just for this video. What findings we have here is that we can easily transform any symbol to Morse with just a symbol mathematical operation if we have an array of these symbols. Or of course it's possible to have some dictionaries with like A equal to dot dash and so on. It will be same easy, but since we don't have it initially, I don't want to spend time on creating it. And if the list will be really high of symbols, it will be harder to represent. So I think that's all. Thank you for watching. Have a nice day.